So in this lecture, let's understand how memory system is organized in the ARM architecture. A number of the modern operating system is running is based on the virtual memory system. If you think about the virtual memory system, and you need to understand that this picture that illustrates how the virtual address is handled. If you turn on the feature of MMU, or if your system is based on the virtual memory system, and what the CPU core is looking at is the virtual address. And if you consider the virtual memory system, there are several components you have to understand. The first component is the MMU. MMU stands for Memory Management Unit, that is placed inside the ARM processor. So every time the ARM core accesses the virtual address, this virtual address is input to the MMU. Since the main responsibility of the MMU is to translate the virtual address into the physical address, and MMU can perform this operation using the translation look aside buffer. Translation look aside buffer is located inside MMU. The translation look aside buffer, that stands for TLB, has the recently accessed the page table. Page table is the key features to translate the virtual address into the physical address, because page table has the information to translate the virtual address into physical address. And thinking about the page table has several information about the permission to access the virtual address and some of the key information about some of the virtual address. But in some situation, the MMU cannot translate the virtual address into the physical address. So in this case, the abort is taking place. And this arrow indicates that the ARM processor will throw synchronous exception when the MMU cannot translate the virtual address into the physical address. And if the translation succeeds, then physical address can be accessed, and virtual address is always translated into the physical address to perform another operation. Another thing you have to remember is that after the translation is completed and physical address can be obtained, using the physical address and ARM core patch the data or instruction from the cache. During this operation, ARM core does not have to patch the data from the main memory and DRAM, because cache is playing the important role to maximize performance. Because in order to patch the data from the DRAM, it requires more cycle time in terms of performance. Remember that every time the physical address is translated using MMU, and then it will access the cache to get that data or instruction. Another important mechanism you have to understand is how the cache is organized. And every time the ARM core tries to access the data, it first patches the data from the cache, not the main memory. And there is a level 1 cache and level 2 cache. This kind of cache organization is called multi-cache architecture. So ARM core always interact with the level 1 cache, which is a L1 cache. And then if the data or instruction is available in the level 1 cache, and then core will do another operation. But if the data is not available in the L1 cache, which stands for level 1 cache, and then it try to check the L2 cache to identify whether the data or instruction are available in the level 2 cache. And if the data is not available in the level 2 cache that core is looking for, and then it will access the external level 3 cache. And then if the data is available in the external level 3 cache, and then it will pass the data to the level 2 cache. And also if the data that is patched from the level 3 cache is not located in the level 1 cache, and it will place the data into the level 1 cache. And this kind of operation is related to cache coherency and data consistency in the structure of the multi-level cache. So every time you look into your assembly instruction, such as LDR and STR assembly instruction, then you will identify that, oh, this assembly instruction is accessing the memory area, but it is important to view the memory system with this picture because internally the virtual memory system is much more complicated than you think. So in this tutorial video, you have explored how the memory is organized in ARM architecture. So next tutorial video, you're going to understand how the memory barrier is introduced in ARM architecture.